Right, so AQA, Pure Core 1, Summer 2010, question 4. So this question is all around integration and differentiation. You're given a curve and you're given the equation of the curve is y equals x to the floor 4 minus 8, oh right, x like that, minus 8x plus 9. And you're given that the point 2, 9 lies on the curve. Um, so first it asks you to find this. Um, so basically integrate. So to integrate, we first just ignore this bit for a bit. And, well, that was the wrong thing to say. Bad habits. You add 1 to the power and then divide by what you added. So adding 1 to 4 is 5, so we go x to the 5 and then divide by 5. So minus, adding 1 to the power is 2, and then dividing by 2, so 8 over 2 x to 2. Plus, and then if you just have a single number, you just go plus 9x, and then of course always plus. Oh no, we're given the values, so we don't need to say plus c. Sorry, I made a mess of that. And we're given the boundaries 0 and 2. So what you do is you plug in the larger boundary first. So you plug it in as x. So 2 to the 5 divided by 5 minus 8 over 2, 2 to the 2 plus 9 times 2. And then you minus the same thing but with the other one. And if it's 0, then it's all just going to be 0, because if you go times this, times this, times this by 0, like if you plug 0 into all of that, it just equals 0. So if your answer is basically this, but let's just simplify it. So 2 to the 5 is 32 over 5 minus, so this is 4, right? 8 over 2 is 4. 2 squared is 4, so 4 times 4 is 16, plus 18. Minus 0, we can forget about that. So this all equals 8 times 2 over 5. And particularly because this paper is a non-calculator, just don't even bother with decimals. Like, you need to just get into the habit of always using fractions. It will become loads easier. Particularly with complicated questions, like you can get in such a mess with decimals. It then asks you, the second part, it then asks you to find the area of the shaded region bounded by the curve and the line y equals 9. So this is the extra information that you're given. So what we do here is we go we take the shaded area, and the shaded area is equal to 18 minus your integral value. And you actually get a method mark if you got the integral value wrong, but you know that. And this is because, I'll explain this a little bit more because I've just been really vague there. So basically the curve you're given is kind of like this. You're given this, you're given this, and this is shaded. This is 2. So currently you found the area between 0 and 2 under the curve, because obviously integrating you find it under the curve. So you found this area, and you're given that y equals 9, so this point is like the part of the limit of the shaded region. So obviously making this 9 times 2 is 18, because that's the area of the square, and then you minus the value that you found, your integral value, and then you get the shaded value. So that's all that's looking for, and that answer is 9 3/5. Again, leaving it as fractions. And that's only 2 marks, but that's quite hard. Like, I didn't really like that one. Okay, so now we move on to BI. So B gives you the point A lies on the curve with the equation y equals x to the 4 minus 8x plus 9. Find the gradient of the curve at the point A. Okay, so what we want to do here is basically differentiate this. So to differentiate this, we go dy over dx equals, so you times by the power, so 4, and then you keep the x, and then you take 1 away from the power. So again, times by the power, so just times by 1 basically, 8, and then you take 1 away from the power of the x, so the x just completely disappears there, and for a constant they disappear. So this is your value differentiated. And then we know that x equals 1. This is your gradient. This, like, right here is your gradient. Because when we differentiate, we're finding the gradient. And we know that x equals 1 because we're given that. So we literally just plug that in. So dy over dx equals 4 times 1 minus 8, so minus 4. And that's your gradient. And that's the answer to that part. Okay, so the last part says, hence, find an equation of tangent to the curve at the point A. So this is kind of, you're looking for, so where will this point be? So 1, 1. So, like, just a tangent is kind of just like, if you go for the point, it's a straight line basically. So you're using your kind of like these are all tangents to the curve. So you're again using your straight line formula. So this one, do you remember this from earlier on in the paper? So that's the gradient x minus x1, and we know that the gradient is minus 4. And we have this point because it's 1, 2, so we know that x is 1 and y equals 2. So you literally just go y minus 2 equals minus 4 x minus 1. And then, I mean, you can put that into the straight line form if you want, but I don't think it's completely mandatory. But this equals minus 4 x plus 6. And there you go. If you found this helpful, make sure you click the thumbs up button and make sure you subscribe to stay informed on what's coming up in the channel.